The wavelength of the energy emitted when electron come from 4th orbit to 2nd orbit in hydrogen is 20.397 per centimeter. The wavelength of energy for the same transition in He plus is, He plus means helium ion. Now 1 by lambda is R by Z square, 1 by N1 square minus 1 by N2 square. So 1 by lambda is proportional to Z square. So lambda Z square is a constant. This we should be aware of for any two atoms. That is a way to handle such problems as a shortcut. Now in hydrogen, for hydrogen it is 20.397 centimeter into 1 square is equal to, for helium plus ion it is lambda into helium is 2 square. So He, lambda He is 20.397 centimeter divided by 4. So anything which is more than 5 is the right answer. 5.099 centimeter should be the wavelength emitted for the same transition from n is equal to 4 to n is equal to 2. In hydrogen it emits 20.397 centimeter. When the same transition takes place in helium, it can emit 5.099 centimeter of the wavelength of radiation. So option A is correct.